Hello, everybody. Good morning, good afternoon, good evening to all of you. This is Daniel speaking. And today topic of the webinar, it's importing any tool components in ToolKit, as it is coming as very frequently asked question on from all resellers and customers on the globe. And I will take this opportunity to just show you the our SolidCAM forum, where we also got like a couple of requests on the turning tools, also about milling holders, inserts, and please visit the SolidCAM forum. It's a great great place where you can just a second. Yeah. Sorry, I just received that. I didn't share the screen. Okay, so hopefully you can see now the SolidCAM forum. So basically, please, I'm inviting everybody that we are really active on this one. Basically, all the questions that you might have, any suggestions regarding to upcoming webinars, the same thing with this webinar series. It came like a frequent request also from the forum. And over here, we have a request to support the twin tool on the turning over here. This webinar, particular today, I will be covering all the tool components that, let's say, milling tool components, okay? The very next one will be, talking more about the turning itself, okay? So my goal today is to show you the most frequently used one on the market, and I will show here examples, the most common that you actually will use on daily basis. Now, one thing here before I continue with the presentation, I would like to also mention that I will talk mainly on medium level. So I assume that you all watch the Getting Started with ToolKit in SolidCAM 2021. So over here, you can go to the YouTube and you can just type SolidCAM Toolkit, and here you will see 10 videos about getting started with it. I strictly recommending you watching that one first before watching actually this one, okay? But yes, I hope you will still enjoy and like it for everybody who's watching it now, and let's get started. So let me go back to the presentation a bit. The theory a bit. So first things first, what are the main benefits of importing any tool components? Yeah. So I'll just try to mention, what kind of difficulties we had in the past and why it is now much better. So first of all, it is ability to use directly imported from the tool manufacturer database. So this is great. First of all, because you don't have to make any your design, so do not waste your time. Also, you don't have to make any sketches or make any shape solids or stuff, So basically, directly from the online databases today, this is well known. You can download many 3D models for absolutely for free, and main benefit of doing that, to save your time and the SolidCAM will basically give you the tool that can directly import those 3D models from the database and use it as your tools. So this is a very first reason. The second reason is managing different tool components from the same tool in ToolKit. To better understand this, you will basically get this point somewhere but in the middle of the presentation. So basically, each component of the holder can be used in any other tool item. Okay, so this is something that I will talk also later. Also, easy definition of complex shape cutters. In the past, we were not able to define any complex shapes, and today, basically, we can do it also for milling, for turning. And as I said, today I will be covering the milling one, and the next presentation will be about the turning one. Also about the shaped cutters, to mention that probably for all of you who are not aware, but I will just mention it in earlier versions of SolidCAM, the inserts for the solids and the insert itself on the turning tools, you were basically being limited of the minimal tool that you can actually find in SolidCAM. So one of the reasons why you would like to get a smaller insert, to have more realistically, simulation. Yes. So at the end, it's the simulation, more precise collision detection, and rest material calculation. Okay. So let's go next. So what do you need to know about the toolkit itself? So behind the scenes, it's behaving completely different in the comparing to the old tool table library, as it has 3 different, I would say, levels. And we basically divided it in the tool components library. Then we have tool assemblies. And then we have machine tool setup library. Now, each one of these, they're very important, but most of all, they're all connected, which means changing anything into tool components library will have directly influence on the tool assemblies library and also to the tool machine setup library. Now, just small talk, regarding this tool components library. It's here in the parentheses, I leave that the extension is TLS, or like tool library storage, while tool assemblies is the place where you will all components from the tool components library, you will merge it into one tool item, basically. And then the machine tool setup library, we will use those assemblies from the assembly library into let's say kinematic level. Yes, basically running using it on a real machine. So this is the three libraries that we have. I will be very focused on this in this webinar. So let's go next. So first, the basic one that we'll spend most of our time is tool component library. Basically, this is the interface. Doesn't look anything so special. On the very left side, you can see you can define all different types of tools and components. But what you can see over here, it's the very first default 3 folders. It is the cutters, shanks, adapters, and holders. You cannot delete these folders, but what you can do, you can add more folders into it. Now, this is important to understand. These are not only folders, okay? This represents the types of the components where it will be inserted. So over here, we have different types of components, and I tried to give you a rough overview what type it's for each folder. So for the cutters, we do have over here, I put like solid tools, shape tools, also the insert itself. All of these you can organize into a cutters folder. The next one is the shanks. So no matter how crazy that looks, but in the shanks folder you will also put the collets, the nuts and the shanks itself, so a lot of things that are not really cutters itself, but they're also not the holders. Okay. And the third one is adapter and holders. You can assume everything that is connected, either any holder, angular one, twin, doesn't matter. They will all go to the adapters and holders folder. All right. And now, once you have a particular 3D model of your tool components, it's divided into many segments. Okay, so on the left side, what I put here is the spindle itself. So it's just a fragment of the spindle here to give a focus on the station. The station and the spindle itself, they are both defined in your VMID for the post-processor, and it has the station where it's basically a position where your tool will be mounted. Now, what is important is that to say that this component, as you can see here, that I will also use in this webinar, is the holder itself, is the shank, is the extension, and insert. This is the example from the ISCAR multi-tool. And why choose this one? I choose it because it's not so complex, but it still has more elements, not just like a holder in the tool. But I want to show you also the great advantage, which I think it's very important in this as improvements in SolidCAM 2021. Now, each of these elements have actually 2 points. The first point over here is the mounting point, and over here at the bottom we have a joint point. Now, the mounting point, it's pretty, I would say, simple. It's basically a connection to the higher component. Okay. Now here I say this to the higher component, but if this element is your very first component, it will be attached to this station itself. So then what we have here, we have additional elements, which they have exactly the same. We have the mounting point and we have also the joint, and also for the extension here. But the tool itself, it has only one coordinate system, which is actually represented over here. I will talk mostly about this, how to export it. And a small secret about it, here we see only one coordinate system, while here we can see 3. Why? Because the last element connects only to one, so we don't need 2 coordinate systems at all. And the biggest difference between this and what we had in 2020 and earlier version is that you had to define your coordinate system on the bottom of your tool, and still you can actually you can also put it there, but because of the joining connection, I will put it also here. I will show you that. So in the next slide, basically the most important thing is that Z goes always up. This is very important. This is how it looks like when it's connected, and basically we have the station, we have the station, the tool item itself is this assembly, we have the holder, we have the multiplex and the shank, we have the extension, and we have at the end the end mill. At the end we have, of course, the cutting point, which actually represent our tool offset basically. Now, what is good about 2021? You don't need to create all your holders, all over again, but you can use any of these components in your assembly and just switch, the cutter itself. So this is how I show it over here. All right, so let's get started with some examples. So let me go to SolidCAM. I didn't run the SolidCAM. Okay. Time for a coffee. So basically, in this example, I'll be using the NTX 2000. It's a simple project that I have basically loaded from SolidCAM 2019. And there are a couple of important parameters that I will show you over here that are important in order to convert from version to version. Nothing so special over here, just a simple test part that are so interesting in the tool library that I will use in this demonstration. What I also have that I will leave in on the website, also you'll find it in description, is the library that I will gonna use in this webinar. So don't worry, the recordings and 3D models, everything what I have used, including the presentation, will be available also on the SolidCAM website. So I decided to use the ISCAR Multi-Master, and over here I prepared like 3 tools. I already imported as a step file, and I just will use it and open it in SolidWorks just like that. Now, what you can see is this is basically what you've seen in the presentation. Okay, this is the assembly that has the holder, the shank, extension, and the tool itself. So let's see how you actually can import all of these, in SolidCAM Toolkit, and what is actually the process of all of this. So The first thing first, so we have the holder. So I'll be now focused mostly on the holder. So I will basically hide all my rest elements. And as you remember, we need to create a coordinate system on which we will later define the mounting position and joint position. The best practice is to create a coordinate system where is the mounting position, so you don't need to later, define the details. But yeah, let me just show you how that actually looks like. So I'll basically create a point, and I think I can do it like on this surface, which will be basically in the middle, and then I'll create a coordinate system. Now, as I mentioned, it's very important that the z-axis is going up, and that's basically it for this holder. I will call this coordinate system of holder. It's better for the later organization. Now I will be basically hiding all of this, and I will unhide this element. Again, the same basically process. I will just go over here, make a coordinate system, and but first I need to define a point, and then the coordinate system itself. I'll just make sure that my z-axis is normal to this surface. It is not important where's my x and y in this case, so don't worry about that. The z is the most important for the milling part. I'll be calling this coordinate system of Shanks. Let's go next. So I will be then unhiding this one. I will just create. Let me try to create like this, the point. No, of course it will not work, but I can do it on the arc. So it should be like this. Sorry if I'm doing like maybe faster than, but I think so. It's not that fast. So just this is a simple way to do it. And then I'll call this coordinate system of extension. And the last thing is the cutter itself. So I'll be just putting it over here as a standard. So nothing so special about it, yeah. So this is how you can actually define all of your standard milling components. That's done. Now, one thing before I start exporting. Now, okay, maybe there will be cases, where you will have difficulties. I will open one assembly of the holder, which you will ask yourself, okay, there is like 50 of elements in that assembly. So should I create these, joints and, all the time? The answer is no. You need basically to group the elements on which you basically think are important. As for example, this shank over here, I would basically like to have a full control of how much he's extended out of the holder. And if this is a case, then I want this element to be separate. If this is something that this extension, it's something that I would like to have, sometimes yes, sometimes no, then this is also an element that I need to export. And this is basically the criteria of how many elements you should have. My best advice, have as less as possible, but of course, try to have all that is necessary, as a component that you would like to later on use it in different projects. Okay, so what I'm going to do, I will hide all the elements. I will just keep the holder itself, and I'll just go and save as. And now the very important point, where am I going to save it? Now, I can save it as, the default is to save it as STL, but where to save it? The answer is like this. Let me go quickly to the project itself. In our toolkit, you can do a right click and reach the settings. There is at least 4 different ways how you can reach the same settings. I like the way how you can do it here. And here you have a path towards the default folder where your tool tables are located. I already have this path, and basically nothing so special. I will just open it, and here I put in a quick access these folders. Here, I usually create a lot of libraries, and just don't worry so much about it. I will just basically start from the scratch, creating everything from beginning. But the most important to mention, that this is the folder where it has to be. Now, if you mention this folder, you can create infinity number of the folders and subfolders within it, and wherever you save it, it should be there and it should be fine. But you cannot, for example, export these STLs into this folder because that tool database will then not see that particular STL. Somebody likes to, to put the C drive, and then the whole subfolders will work for him. But I will not advise you to do that. I'm more to be more organized in this case. So let me go back to our export procedure, file, save as, and I'll change here to the STL, and I will go to my metric folder, and I'll create here, the folder. Now I will advise you to create the folders based on the tool manufacturers or maybe tool type or however you want. It's up to you. And for this reason, I'll just call it a webinar. Just we'll store all our tool files over here. The name, okay, interesting. Let me just cancel, and I want to grab this name itself, so I'll just copy this and just make a save as. Go back there again. Metric, webinar. I also like a webinar because it's the last folder there, and I'll be calling it. It will be the STL. I'll go to the options, and this is something interesting. So I'll start from the top to the bottom, and the output must be binary. Now the resolution. Okay, so for the most important elements like the cartridge itself, I will always advise you to go with a fine. But for the not so important elements of your components, I would advise to use the coarse because it will create a database that is more not more faster, but it's less in size. Of course, manipulation with such a database would be much faster at the end. So for the not important elements, try to use this one over here. These tools are very important. Actually, this particular one, this particular one is the most important. So you must use this checkbox. Okay, do not translate STL output data to the positive space. And here, this checkbox is optional. I don't use it in this example because I hide all the rest of the elements, so I don't need to save it as a single file. But the output corner system is very important. So in this case, because we organized everything well, I'll just click on the corner system of the holder. I'll click OK. All right, I'll just save it. Yes, that's it. Now I'll do the same thing for all the rest elements, and I will not forget to copy the name itself. Let me go back there again. Metric, webinar. So just like this. And this time it's corner system of Shank. Don't forget that. The rest looks good. I'll just save it and exit. Now, probably while I'm doing this, you will probably ask yourself, okay, Daniel, would you show us this, for every other example? I would say no. I will basically showing you, just the basics, and then for the rest, it will be different way. So, oh, of course, while I was talking, I didn't take this. All right, so metric, webinar, and I'll put it here. Great. The name itself, it's not so good. If he has this one, the Windows will not allow you to do that. I'll just put dot. Option is the extension. Save, yes. And the last is the end mill. I'll just do the same. All right, so step, final. And the last one is the quota system 4. Okay, the name, it's okay, and save. Right, okay, we are basically ready. Let's go back to SolidCAM. As we mentioned in the beginning of the presentation, each SolidCAM has 3 levels of the libraries. Doing the right click on the toolkit in the CAM part, you can edit, create new or delete any tool library. And of course, you can edit your part tool library. In this case, we're going to create completely new one. So I'll just go tool component. This is what I mentioned earlier. Basically, you will have three folders. This is how they look like. And you can create a new folders. You can be more organized. It's really up to you how you're going to organize your folders within your tool library library. In this case, I'll just use a simple way, just dragging it to this folder. So let's start with the holder itself that we create. So I'll click on the components here, and here we have the holder. So I'll drag and drop it over here. Now, with this particular holder, you can define it as a shape or 2D. This is still a remain from the earlier version. You can still use this one, use the custom shape that you can find it over here, put the values, boom, it works, okay? You can also import it as a sketch. There's also option for it. Now, in this webinar, I'll be all the time using the 3D model from tool manufacturers. I'll click on the 3D model. I'll click like this, and I'll find this webinar and HSK A63. I'll open it. Now, you probably remember from the presentation, each of the components has 2 points, the mounting point and a joint point where the lower level components will be attached, right? So all those things will be handled basically in something that we call connection, that you can find it over here. So click on the connection. And what I like to do, I like to open show and hide tool picture. It gives you, better representation what we are going to do, what we are doing here. So there is 2 coordinates, as you can see here. And here you have like, I would say 3 separate areas that I like to mention. Let me do it like this. Okay, so the first is the mounting point. You can basically say where you'll be mounting point regarding to this coordinate system. This C that you can find it over here is your STL output coordinate system. And then over here, you can find the list of all your joints. So you can have 1 or more joints. Each joint, actually its position, orientation, and drive unit type will be actually defined over here. So as my mounting is also the coordinate system over here, you can see it. If I try to move it, you will see this coordinate system here. But in this case, I will just leave it as 0. It will be equally, my mounting point, and I will leave it as it is. But what I do have here, it's the joint 1. It will be created basically automatically. And over here, we have a coordinate system. So the coordinate system will basically say, okay, from the mounting coordinate system where you want to be, and I'll just move it there. And I can guess it's very good preview. I can just move it like this. Like I say, it's 80. If you're not sure about it, you can also do a measurement. You just do your right click and click measurement, and you can now select the surface, hold the control key, click over there, and in the corner, the distance dialog will pop up. What is the real distance there? Right. So I'll be writing here -80, and that's basically it. Now, there is something about the drive unit type that I want to mention before I continue. So let me go back to the presentation itself. So there are different types of holders. As you assume, there are some that transmit the drive unit directly. There are some that are not driven. There are some that are self-driven, and there are some that it's a gear. Okay, so all of these can be defined over here. And I just put in the images here what you should use as a drive unit type when you have this particular holder itself. So the gear will be always used something like this. The self drive for the I forgot now the name. For the turning tools always, and center drilling, you can use not driven, and then direct when it goes directly to the spindle unit itself. So I'll show you basically most of these today. Go back over here. Right, so what is our drive unit name? It's direct, so I will not change anything else. What I would like to do actually is to close this, go here, and I just forgot to be more organized, so I'll just take this name and do a right click, we can rename, and here you go. Perfect. Now the Shanks. So we have the shank. I'll take the square shank here. I'll just put it there. Now you'll be maybe confused why we are using the shank. Currently, we don't have the really icon, for these kind of components. Probably in the future we will improve the icons itself, the way how we import those kind of things. But for now, just take the square shank. It's not really important. Here you have parameter data, but you can also import it as a 3D model, which will be considered like a different different element or component. Now I will take SA. I think it's this one. I'll take it. You can use the preview. I will rename it. Let me try to minimize this. I don't have to make it so big. Like this, it's enough. Maybe smaller. Okay, connection. Put the connection all to 0. I will do that right now. And I will just use, measuring, click, hold the control. I like to put it here. It's 65, so I'll go minus 65, and my joint will be here. So that's it. It's my static point. You can also rename your joints to whatever you want, and it will be also displayed over here. Let's go next again. This shank, I will just go to 3D model, and I will be taking this cap. Okay, here we go. I'll go to the connection, take here zeros, and now I'm going to take these, take this. What, we do have a angle here? Okay, good, but it's not a problem. You can click on the point, hold the control, and there is like 25.4. Okay, so minus 25.4. Is that it? Yeah, perfect. All right, so rename, put it there. And the last is the cutter itself. So the cutter is the end mill. So I'll just take the end mill over here. There is a list of the end mills. Here's the turning cutters. I'll take the end mill. I'll just drag it here to the cutter. And basically the more or less same procedure. I'll just go to the 3D model, and I'll check this out. I will go to my webinar, and I will take this one over here, load it. We have it over here. I can also rename it, and that's basically it. So you can continue doing this, and once you basically finish it, you go to the file, save as, and now as you can see, it will the default folder will be there. And basically what you need to do is just to name it. And in this example, I will also call it like webinar. And you can know that it's TLV, which is the vault itself, so tool library vault. And I'll just save it. Super. So I'll just exit here. And okay, we are still in the pod. So how we can use this? Okay, so you can basically go directly and make assembly in your part tool library. But I want to show you, creating it from tool assemblies. Okay, just to show you, different levels what we have here, itself. So what I'm going to do here, I will just show you a couple of things. This is the dialog of the library, and as you can see, these are split into two. And if you want to import anything from any other library, it's so super easy. You go over here on the left side of the screen, and here you have a very nice icon which represents the vault, and it says import from tool components library. And you can click it over there, and you'll find your webinar.tlv, which we just basically saved it. Now, very important detail here. If you are one of the customers who are creating, the tools based, starting from the bottom to the up, which means starting from the cutter, then this simplified view, I call it, or standard view, you must start it from the end mill. So just drop, the end mill like this, and then you can build your holders. Okay. Now I'll not do it like that. I'll just try to delete it. But I will just showing you the advanced view. The advanced view, it's basically like swapping it up, but what will it allow you? It will allow you to start building your tool from the holder itself. So I can take the holder, adding the holder, which will automatically create a tool item 1, where you can type any tool number, IDs, anything related to the offset. And then we will just take, just drag and drop as a Lego. Here you go. Now there's a couple of things that we need to do. As you remember, we just put all the coordinates there, and I put it for a good reason. If I click it over here, now I have a connection and manipulation to say where my element will be. And very nice tip for you, you can also do a right click and you can make a focus, which will basically focus and highlight only the element that you are actually now modifying. The extension I will not change. What I will do change, it's my Z over here, which I will just change it to 0, and here you go. What is so nice about this is that my cutting point, if I go to my topology, it's automatically detected as diameter of 10. As you can see, this point over here represents your tool offset length, while this circle over here represents your tool diameter for the compensation. Okay, where your radius, where your compensation will be in radius, which is half of the diameter. Great. So this is our first tool. I hope you like it so far. Let me just quickly go over the. Oh, there are tons of questions. Oh, okay. I answered half of them during so far. Yes, also, Stefan, thank you. On the presentation I put for the assembly, for the, how's it called, for the tool library assembly, it's not till A, but till S. Okay, so good point, Stefan. Yeah, okay. Okay, so let's continue. So what is good about this? I like this. It's so great, so nice. I will go to the cutting point. And what is so nice feature in SolidCAM that all of these elements on the machine will be basically removed. Okay, so before I do anything, I like my assembly. And what is, yeah, I'm jumping from subject to subject, but basically I want to show you one very nice feature here. So as we have here now tool item 1, you can now see actually the real power and all what I was talking, earlier, all the power behind the scenes. I can just take now this copy. I can, create another tool within the same assembly, which are completely using the same elements. But what is so good that this one, it can be completely different position of any of the elements. So I can click, I can go over here, I can change the extension. It can be like this. I like it. So this element, it's like this element, it's different. I can also copy it, I can paste it. I can say that, oh, I don't want this extension. So no problem. So I'll just take this end mill, put it on the main one. I don't want this extension. Here we go, directly. So now I have three items which are completely different. But what is the most important? If you remember my first slide, I talked that each of these libraries, they're all connected. So clicking on any of these items, you can note where they are linked. You have this like a link icon, and here at the bottom, you have that information on which library actually he is connected. This directly means if I override this STL, I don't need to redefine everything again. It will automatically take this change. I can also update it by doing the right click, I can update it. In the case I used any of these like numbers, shifts, pardon, I can also do right click and reload, which means that he will put all the things to the 0, which was here 30. But if you want, also you can break a link. Breaking the link will basically currently disconnect from the library itself, and it will allow you to make any kind of modifications on local level. Okay. Right. I hope you liked so far. Let me add more things to my tool component, which we are basically jumping into my next example, not FlexFit, but Multimaster. And this time I have just loaded, the slot mill. I just remove all other elements because I don't need them. I put my coordinate system, and basically what I'm going to do, I will just make a save as and put it into the right folder. How we are going to call it? I'll just simplify it. I'll just call it slot mill. Now, as it is a cutter, I will use this as a fine. Great. Okay, close. Let me go back over here. And what we are going to do, I will now edit it for the first time. Editing any tool components will have directly influence to the assembly as well. So I'll just go over here. I'll click on the webinar. Here I have again my tool components that we have used, and I'll just add a new cutter. This time it will be slot mill. I'll just edit. I will, instead of parameter data, I will use 3D model. Very nice. Let me go here, put the slot mill. What is so nice that he will automatically detect his diameter. Pay attention, if it's a low quality STL or something, you can also make it rounded like this, and that's it. Also, this is like a whole cutting length, but it's not necessarily have to be whole cutting length, so you can modify it. It cannot be higher than this value. So if I try to make it higher, then you get this error message. Hey, you cannot do that. There is no 3D data there. But you can make it smaller. Yes, as you can see, it will dynamically show where is your cutting. So I think for this one, it's 2.5. And that's basically it. So I like it. I'll just save it, save and exit. And again, I will now edit, but this time tool assemblies. Oh no, did I? I didn't save my assembly. Great. So new, did I? Maybe I didn't. Tool assemblies. Ah, pardon. So I save it into, so let me do a save as. So I'll be saving this also as a webinar, but this time it's still as Frank says. So I will save it like this. Again, I'll just make a copy, and now I can do paste. And what is great about this, I can now replace my end mill. Now, there is a couple of ways how we can do that. I like 2 ways. Simply just clicking on delete key, right click, delete, or just clicking on your keyboard. But what you can do, you can directly import it and replace it. The way to do that is so super simple. You just go to the import, you just go to the webinar, here's your slot mill, and before you're making a drag and drop, okay, making a drag and drop will add him below this, okay? So, but if you hold the Alt key and then putting it over here, it will basically replace it. So the only thing what I have to do is go to the connection and change this connection here. Here we go. I can maybe put it like, I don't know, like 5, but in minus. Not exactly, maybe 2. Yeah, something like this, it's okay. Great. With this, I would definitely like to use extension. I cannot do any slots with this. So what I can do, there's also undo button if you miss something. Where's my extension? Here we go. So what I can do, I can copy this element and I can just paste it over here. It's super nice. I like it. Drag and drop slot mill here and voila. So you have the extension, very fast, very nice features. I all like it. All right, let me see your questions here quickly. Okay, great points. So there's a question like how to define the milling cutters in the case when you have an insert. It's coming right now, okay? But before we're going to the inserts, I will just like to show you one thing here. It's the part tool table that I'm going to use in this case. And as you can see here, this is how the part tool table looks like. This is our magazine over here. I will show you just quickly a machine. I will just run it on the right side. Here, this is what we have. Don't worry about the positions. I made it incorrect because I want to show you some features. And there is how to import basically this component. So you can do it directly into tool components library or from tool assembly. I'll show you that. But let me do that pretty quickly. So this is how to import it from the tool components library. So you can basically use the same techniques as I show you also in this environment as well. But this time I would like to actually import it from the tool assemblies library. Find it over here. Here we have it. And maybe I can import them all, but in this case, maybe 2, 3, 4. I think that will be enough. And you can also, you can do it and just click select. You can do a right click and mount it to our magazine. Also, another way is to do just to exit here, and you will find it also here. It's so nice. And just drag and drop. But I want to also show you something very nice. In SolidCAM, I also mentioned that there is advanced view. You can go to the view and jump to the advanced view. You can also use the F9 key shortcut, which will basically allow you to work directly on the kinematic, which you can see each position, or we call it also station, available on the lower turret, also available on the upper turret. And here we can say real machine magazine, where we have at the moment 7 tools, loaded there. So I will take all of them and just, drag and drop and all. What I can do only like this. Okay, so let me just do it like this. Okay, perfect. As you can see, these are not imported. These are important for the previous version, and they don't have any icons. While this one have the icons of the link, which means any change I perform, it will reflect it also over here. Right. Now let me mount any of these tools. So let me mount this to the station. I can see it over here. Very nice. I can also mount my T-slot. Looks beautiful. But there's one thing here. It's connected to the question that I got, like how we can use the insert cutters and mills, indexed end mills, it's called. I'll just show you right now. But what is a very important feature there? As you can see here, this is real solid, but they are not revolved. In order to have it revolved, of course, in the simulation, it will be revolved, but pardon. But I want to see it also in SolidCAM. So I want to show you one feature that you can change in your VMID file, but I will strictly recommend to not do that because it can change a lot of things in your post. So I will recommend you to first contact your local support before changing this parameter. I will mention the most important parameter that it has to be modified. So in the working style here in the toolkit, you have 4 parameters which directly affects to the toolkit itself. It's the delta for tool H. It's pretty old parameter. Then we have toolkit advanced mode view, which I would say here yes. So every time when I load my tool table, it will go to the advanced view. And here I have default machine tool setup library. So once I save all the things, I can save particular tool setup for the machine, and I can use it as a default every time when I start my CAM part. And here I have a revolver holder for milling. I would say this to yes, and I'll exit. Now, not all the things will work. It depends from machine to the machine. And let me go to the machine itself. Actually, I can do it over here. And what you can note is that clicking on the T slot will not change anything, but clicking on the cutting point, it will start revolve your part. Your tool itself around the axis that is along the Z. Now, there are a couple of things what it has to be. Here, there's some missing elements. Probably I made something wrong, or there is it, but let me try to attach any other. Yeah, this element did something. Okay, but basically you can see here that this element is actually spinning. So this is important for the for this parameter. Okay, let me just go over here, and this is what you will actually also see in the simulation. So real revolved feature of your tool component. Now, the things that affect this parameter, so what you will have to change and modify, as I said, for the customers, please contact your support. For all the resellers, I would just advise to make your, the station where the Z is in to spindle, let's say like this. So this is the first parameter. And the second parameter is that, default tool direction affects directly of what is the vector of revolution that will be used in this preview. Okay, now about insert indexed cutters. Okay, so I will open another example. Where it is. Okay, so basically same holder, same elements, but here what we have is the kind of holder for the inserts, and we have two inserts. But what is so important about them is that they are not really like perpendicular or normal to this surface over here, but they are under some angle. So stay tuned. It's very important, all the steps that I'm going to make. I didn't create all the quarter systems that I need. I only created this one. It's for this component over here. But for the inserts, it will be I will create it basically now from the scratch. So stay tuned. So the very first thing what you need to do and to have is the direct connection of where your, let's say, mounting coordinate system is located in according to where is your insert. So I need to know the distance and orientation of that coordinate system. So the rule is, it has to be, we need to have this place. So what I'm going to do, I will just basically create a sketch there, and I'll create a point. Hopefully it will allow me. Yes, it's over here. I need just a point in order to create a coordinate system, nothing else. The coordinate system over here, I will just create the coordinate system that is the Z is very important, where my Z is normal to this insert. But as you can see, the insert has some angle here, so I cannot really use any of these. So I can basically use maybe this surface. Yeah, that will actually work. No, the second plan would be to create a plane that is on this edge, but actually I don't have to do it right now. Okay, now one thing to mention here. Importing the inserts for the milling and turning, it's not the same. Okay, so this is something that I will emphasize in the next webinar. So stay tuned about that as well. Okay, so whatever I'm showing you right now, it's only for the milling cutters. So I have this quota system, and I will call it joined, and the same thing, same quota system I will use for the insert. Right. So let me export this. How I'm going to call this? Is there? Cool. So let me hide all others and also 2 inserts. Okay, and let me just now export it. And I'll export it to the same folder. Let me go webinar, and maybe I can create a folder, and I'll call it Indexable. And I'll just call STL. This is my name. Nobody likes this. I'll go to the options, and it will be my MCS goals. That's it. I'll just save it. Done. Then I will just unhide the insert only, and I'll just do save as, and I'll do the same thing. So I'll go to the metric. I will go to let me see. Webinar, Indexable. I'll call it just insert for now. STL, options. This time it's the quota system 1, and I'll just save and exit. I'll say yes, great. Okay, so next step. I will leave it as it is. I will not close this project, okay? I will go to my SolidCAM and I will insert these components, and I will do it in my tool components library, and I will load my webinar, and what I will have is the shank itself. So I will just insert the shank, and then I will use my 3D model. I'll go to my webinar, Indexable, this one. Okay, now the interesting thing is, here we have this element. Here we have our, let's say, connection point to the higher level elements. And now we need somehow to mention this point and to put it over here for our joint. Now, this isn't so easy, especially because there is an angle here. So therefore, I want to show you, I'll just save this and exit. I want to show you, as you can see here, I highlighted over here in the ribbon, it's SolidCAM Utilities. If you go to the solidcam.com and go to the download section, you will find the SolidCAM Utilities, and basically the quota system matrix. Over here, it will be shown. This is a completely new feature that I'm really recommending you to use it in order to grab all the necessary info between the 2 quota systems. So I will just go over here, and I will open, not that one, this one. And I will take this opportunity to say special thanks to Stanislav Avrik, who actually built and update this great utility. Thanks, many thanks to him. And basically, the steps that you need to take in order to check them out is to very first select the first quota system, then with the control key, the next one, and click on the quota system matrix. You don't really necessarily have to do it in that way, but I think it's the fastest way, as you can do this also manually later in the dialog. What you have here is the shifts, and you also have the rotations. So this is what we have to apply. I will just, for this, I will just, copy this, and I will just move it to my another screen, and I'll exit here, go back to SolidCAM, again, open my tool component library, go to my shank, let me just rename it, that's it, and connection, great. So I'll keep it zeros, and I'll call insert position, but you don't have to really do that. So my shifts are 2.7, 1.4, and minus 7.5. And the angle is just like 97, 2.108, and here we have 0. As you can see here, we have our coordinate system basically imported from the SolidCAM utility. Great. And now the insert itself, as it is for the end mill, you just take the end mill, just like that. It's a 3D model. Go to the webinar, Indexable, and the insert itself. I will not touch anything. I will just call it, insert kind of end mill. You can do as you want. I'll just save and exit. Okay, now let me go to the tool assemblies. Okay. And I'll just copy this tool, just something where I can work. And instead of slot over here, maybe I can basically remove this one. Great. Import from Vault. Here it is. And insert. Here you go. Now, there's one thing that I forgot to mention here. Where's my second insert? So let me just show you the great connection between two libraries. Again, I will go to my tool components library. I will go to the webinar. Oh, sorry, I will go and open my webinar. It's already too much. So, and I will go to this one. And there is a great feature that you can do here. If you have more positions, you don't really necessarily have to create like a more joints, but you can use a pattern feature that you can find it over here. And I will go here, number of items, I will say 2, and the shift is 180 degrees, and just add it. I don't need this one. Recreate, sorry, like this. Okay. Save and exit. Go back to two libraries. I hope I saved it. Yep. Yes, I did. But now you can see that our item give us like a traffic light saying like, hey, this component is changed. Do you want to update it? Now you can update it or keep it as it is. If you want to update it, just click on update component, and this time you have both inserts. Clicking on the insert itself, it will not spin it here because it's because we are in assembly. We are not in the part mode basically, or kinematic mode. And of course, the insert here you need to change the diameter itself. So you need to know the diameter here. So I'll need to go back again, but I will not do that as I want to show you one great feature. You can do it, right-click, insert on the insert that we just did, and you can break a link. And breaking the link will basically allow you to do anything. Yes, so I will just make it make it smaller as it is. That's it. Okay, so this is 10. Okay, and the last thing that I want to show you is how that looks like in SolidCAM afterward. So let me just open it. I want to use this one. Load it over here. Thank you. I think it's this one. Is it? Yes. And just right click, mount, open the preview. It looks fantastic, really well. Exit, click on the cutting point, and it's rotating. Now I'm not sure why it's also removing this element. I'll check that out. But this is basically all for the first webinar series, okay, in this series. So I planned to actually have only 2 webinars, like 1 milling, 1 turning, but it turns out that it's too much. So please stay tuned. The next week I will be creating the additional to this with indexable holders, with angular holders, and very much more. And for the last, I'll just take the questions. As you see, no, okay. So the question is, do we have to use the end mill? No, you can basically take any other element, not only the end mill. Here I use the end mill because really for the elements that I need later on here, I use basically the end mill, but you can use appropriate tool as well. You can use the drilling as well. Yes, so this is also a good question. Angle difference, should we have defined again? No, okay. So the question is like, do we have to recreate, or so basically you need to put one item there and 180 degrees. So this is the original one, and just an additional one, it's 180. So okay, so the turning tool will be on the next webinar. No, actually, the next webinar will still continue with the milling one, as there is a tons of things also to show you. It will be maybe shorter webinar than this one, but I will. So the turning webinar will be basically in 2 weeks from now. So oh gosh, it's 13. Yeah, it will be on 13 D-Day. Will you have? There's also long questions. Okay, so guys, I think I will not forget, to answer on all these. I will collect all the questions and ask personally. I will also, for the most frequent questions, I will also mention them in the next webinar. I hope you like it. I hope you enjoy it. For now, I would just like to mention that I'm expecting you in this number also next time. Stay tuned, and don't hesitate to visit our forum. I will just repeat it. And for any suggestions, please, everything what you write there, we are seeing it, okay? So we are not ignoring them. I wish you very pleasant holidays and weekends, and goodbye.